Hi students. In this lecture, I am going to discuss problems based on moment of inertia. Let us see first one. Right, see the question given. Let I be the moment of inertia of a uniform square plate about an axis AB that passes through its center and is parallel to two of its sides. CD is a line in the plane of the plate that passes through the center of the plate and makes an angle theta with AB. The moment of inertia of the plate about the axis CD is then equal to. So asked for 2 marks in 1998. Let us see what is the question given. So first make a diagram for the given data. So it is given now square plate. So it is a square plate and given condition is AB. AB is now one axis parallel to two of its sides passing through center, and CD is a line in the plane of the plate. This is now AB. And you can see CD is a line in the plane of the plate, passes through the center of the plate and makes an angle theta with AB. Again, passing through AB. Let us take like this. This is now CD, which makes an angle theta with AB. So given that about AB, a moment of inertia, IAB, that is given as I. So about CD, what is I value, right? If you remember, while discussing question number 21, same question we have solved. See carefully. This is now square plate. Consider this as x-axis and this as y-axis. About x-axis and about y-axis, I value same. Okay. So if you want to calculate about z-axis, about z-axis, it is equal to ix plus iy, right? And we are knowing that ix equal to iy because distribution of mass about x-axis, about y-axis, both are same. So here condition is ix equal to iy. And that value how much? If side length equal to L and mass is M, it is ml square by 12. Okay. Now here what I am saying is, if we rotate these two axes, x and y, by any angle, okay, if we rotate these two axes in the same plane through any angle, still same relation valid. That means iz equal to ix plus iy and ix equal to iy. Now same logic here. It is just rotating now these two axes. Now this x we are taking as AB. Now rotate this x-axis by angle theta. That means now CD becomes x-axis and normal to CD that becomes y-axis. And again same result. That means about CD also it is I only. Okay. It is not depending on angle theta. So this is the result which we have discussed in question number 21. Okay. So answer is now it is option A. right? Let us see next one. A solid sphere of radius capital has moment of inertia I about its geometrical axis. If it is melted into a disk of radius smaller and thickness d, if its moment of inertia about the tangential axis, which is perpendicular to the plane of the disk, is also equal to y, then the value of r is equal to. So asked for 3 marks and very simple question. Just see the condition given. It is just writing the given condition. So first given solid sphere, moment of inertia is I about its geometrical axis. That means it is about diameter of the sphere. About any diameter, its moment of inertia is, it is given I, which is equal to 2 by 5 mr square. Okay. Now this is melted, converting into disk, right? So now converting into disk of radius is smaller. After melting, mass does not change, m only. And it is tangential axis, which is perpendicular to plane of the disk. That means see, it is normal to. So that given axis, which is the tangential axis, that is a parallel to its own axis. Okay. Suppose disk is now in xy plane. Okay. Take origin is now center of mass. So here z axis is now its own axis. And this is a normal to, sorry, it is a parallel to z axis. Okay. That means now this value how much means I equal to mr square by 2 plus mr square using parallaxis theorem. So it is equal to 3 by 2 mr square. Okay. Tangent normal to plane of the disk. This is what we have discussed in the earlier lectures, right? So now condition these two are equal. So just equate that. So we are just taking the given condition. 2 by 5 mr square is equal to 3 by 2 mr square. Mass cancelled. 2 2 so 4. This is 15. So r equal to 2 upon root 15 r, right? So just a matter of writing the given condition. Then we get the answer. It is a very simple question asked for 3 marks. Okay. See next one. From a circular disk of radius capital R and mass 9m, a small disk of radius r by 3 is removed from the disk. The moment of inertia of the remaining disk about an axis perpendicular to plane of the disk and passing through O. So here O in the sense it is center of the original disk. Okay, means this point. So what we are doing here, from a bigger disk removing a smaller one. So for remaining one, about original center of mass, what is I value? Axis perpendicular to plane of the disk, right? So asked in 2005. Let us see how to solve it. So first make the given diagram. So from a bigger disk, its radius is r. So we are removing a smaller disk of radius r by 3. It is r by 3, right? So this separation that is equal to how much? 2r by 3, right? This total values are, this is r by 3. Remaining is now 2r by 3. And so what else given here? Its initial mass, right? Original mass 9m. Okay. This is point 2. So here the main key point is, first we are finding about this center of mass for before removing what is I value. Okay. So before removing I value about O, okay, that is equal to its mass 9m into r square by 2. Okay, like mass into r square by 2 about its own axis. Okay, so now we are removing a small disk. That means now what we have to do is calculate for removed one moment of inertia about the same axis. Then we have to subtract. So whenever we want to add or we want to subtract moment of inertia, it must be done about the same axis. So what we have to do now? For the removed part about O, what is I value? Then subtract that from this initial value. Okay. So key point is, whenever we want to add or we want to subtract moment of inertia, it must be done about same axis. Okay. Right. Let us see for removed part moment of inertia. Let me take it as this is I dash. For removed one, we are knowing that mass is proportional to square of the radius, right? I will write here mass of a disk is equal to its area pi r square into thickness of the disk, that gives volume into density, that is mass of the disk. See, once we are taking a disk area pi r square. Disk is having some thickness. This gives us volume into density, that is mass. Now for removed disk also same thickness, same density. So only change is now radius. Therefore, mass proportional to square of the radius. I hope you got this point. Okay. So here for removed part, radius is r by 3. For bigger one, it is r. Okay. That means for removed one, mass becomes 1 by 9 times. Am I correct? M proportional to r square. Now r is how much? R by 3. So mass becomes how much? 1 by 9 times. Original mass 9m. So 1 by 9 times means for removed one, mass is m. Okay. So about its own axis. Okay. Moment of inertia will be m square of r by 3 by 2. This is about its own axis. Okay. Next, but we want to calculate about O because we have to subtract, and when we want to subtract, it must be done about same axis. So this is about its own axis, means about this axis. Okay. Plus, I am taking now parallel axis theorem plus m into square of the distance between the axes, right? That is now 2r by 3 distance equal to, so it is now 2r by 3. This is moment of inertia for removed one about axis O, right? So now for remaining one, let us take it as I suffix r. For remaining one, original value minus for removed one. Okay. Now substitute values here. Let us take mr square outside. Remaining is 9 by 2 minus, this is 1 by 9 and this is 2, right? 1 by 18 minus 4 by 9. Okay. And see, this comes out to be how much? mr square. Now simplify this. This comes out to be 72 by 18, right? Then this is here how many times? 4 times. That means our final answer is 4mr square. Okay. So here you have to keep in mind, when you want to add or when you want to subtract, find I value about the same axis. Then only we can subtract or we can add. Okay. Let us see next problem. Let's see the question. A lamina is made by removing a small disk of diameter 2r from a bigger disk of uniform mass density and radius 2r as shown in the figure. The moment of inertia of this lamina about axis passing through O and P is I naught and IP respectively. Both these axes are perpendicular to the plane of the lamina. The ratio IP by I naught to the nearest integer is, so asked in 2012, almost same as the previous problem. If you remember, in the previous problem, we have made calculation about axis O, right? So here we have to make calculation about P also. Then taking the ratio. So process, there is no change, same as the previous problem. Only thing is, we have to make calculation of twice. One is about O and one is about P, right? Then we can take ratio. Okay. See calculation. Right. First of all, see diagram given. So from a bigger one, removing smaller one. And how this is removed means removing from the edge. It's right like this. So this is given to R and this is also to R. Okay. 2R and 2R. So we have to find now moment of inertia about O and about P for remaining part. So again, same as the previous one, just making calculation twice. Let us see now. First, see calculation about O. Okay. About O, I not equal to, before removing about O, see how much. If mass is M, it is M, radius is 2R by 2. This is moment of inertia before removing this part. Okay. M square of the radius by 2. Okay. Minus for removed part. For removed part, first focus about its own axis, means about this axis. Okay. You can see here, for bigger one radius 2r, for smaller one radius is r, means it is radius is a half. And just now we have learned mass proportional to square of the radius. Now r is a half, so mass will be 1 by 4, right? So it is m by 4 m r square by 2. Okay. This is about its own axis. Let me call it as A. Okay. About axis A. About own axis m r square by 2. Next. But we want to calculate about O. Okay. For removed one, for removed part, about O. That means this becomes now tangent. Right. Tangent normal to plane of the disk. Right. So plus means by using parallax theorem plus its mass m by 4. Distance how much? From here to from A to O. Distance equal to R. Square of the distance. That is I naught. Okay. See how much we get. Let us take m r square outside. Remaining 2 square 4. 4 by 2. It is 2 minus. This is how much? It is 1 by 8. 1 by 8 minus. This is now 1 by 4. So m r square 1 by 8. This is now 2 by 8, right? 2 by 8. So 2 minus 3 by 8. Okay. This value becomes how much? 13 by 8. Okay. Now in the same way, calculate about P. About P. So we are saying that if you want to calculate, means if you want to add or you want to subtract, we have to make calculation about the same axis. Before removing about I, okay, means about. So before removing, we want to calculate about this axis, right? Then see about that axis, what is the value? This is a point is P, right? Not I, it is P. Let me correct it. It is P. About P. About P means it is a tangent normal to plane of the disk, right? Normal to plane of the disk. It is equal to, it's about tangent normal to plane. So this is 3 by 2. Before removing 3 by 2 m. Radius is 2r. This is before removing. Okay. From that we have to subtract for removed part. For removed part about P, what is I value? Okay. Again, first calculate about its own axis. That is how much? M by 4 r square by 2. So right here m by 4 r square by 2. This is about its own axis, means about A. Now we have to find out about P. About P. About P means now what happens? Distance. See A to O. Distance equal to R, right? See carefully. A to O, distance equal to R, and O to P to R. So A to P, distance how much? It is R square plus square of 2R under root. That is now the value of EP, right? Now take here, it's a mass m by 4, square of the distance. That becomes how much? 4 plus 1, 5, 5R square. It is a 5R square, right? Now simplify this. Take mr square outside. This is 4. 4 by 2, 2. 2, 3 is 6. 6 minus 1 by 8 minus 5 by 4. And see this value how much? mr square into, this is 37 by 8. Right? Now see ratio. We want to calculate. We want to calculate IP to I naught. M r square gets cancelled. 8 gets cancelled. Remaining is now 37 by 13. Right? This is now 2 point something, right? So 13 and 37, 3 13s, it is 39, right? 3 13, 39. Means closer to, mean this value will be 2 point something. That is a closer to 3. Because it is asking like, it is the nearest integer, right? So that value will be how much? 3. Approximately 3. Okay. That is our answer. Okay. That means the previous question and this question both are same, right?